So we are going to learn about finite automata. It is considered to be a mathematical model of a system or a machine. So it is a mathematical model. So for a particular system, there could be certain inputs for which we want to perform certain actions, and then we want to get to certain output. So we'll be learning about the components first, and then we will see the working, and then we'll see few examples through which it will be more clear. So what are the components of finite automata? So it consists of finite set of states, input tape, and a read head. So for a particular problem, whichever input is there, it will be written into the input tape. Then there is a read head which will read that input, and finite state control is there that will help us in getting to certain states, and based on that we can decide what will be the output and other things. So input tape for a particular problem, input is A and B, finite state control is there, and then we have the read head. So how does it work? So depending on the state and input symbol. So there is a particular state here and input symbol, in this case it is A. So depending on the state, which could be Q0 or Q1. So in Q0, if we get A as the input, which state should it go into, or it should remain in the same state, depends on the problem. So this is a model of finite automata that we need to keep in mind when we are solving the problems. So when we'll be seeing the problems, that time we should remember, like there will be an input tape, we have a read head and a finite state control. Now, finite automata moves the head to the right of the current cell. So once it takes certain input and it has certain state, based on that certain changes are happening. After that, it will move to the right. So the movement is from left to right. So that we should remember, it is from left to right. We cannot come back from right to left. In finite automata, that is the case. Then what are the different variations of finite automata? So we'll be learning different types of finite automata. So first one is finite automata with final state and no output. So there will be a final state in this particular finite automata, but there will be no output that we will be getting. And there is another type which is finite automata without final state, but it will give a certain output. So under the first category, that is finite automata with final state and no output, we have two: deterministic finite automata, also called as DFA, and non-deterministic finite automata, NFA. So we'll be learning about DFA and NFA. And then finite automata without final state, but it has an output. So we are going to learn about Moore machine and Mealy machine. So these two machines we'll be learning. So first we'll move to the deterministic finite automata. So what is the definition of deterministic finite automata? It consists of a finite set of states. As the name suggests, finite means it will have certain finite set of states. There will be a state called as the start state, and there can be one or more final states. So we can have one state or more final states. At least one is required. In DFA, from each state on each input symbol, there is exactly one transition. So that we have to remember. This is very important. Each state on each input symbol, we have one transition. And it can be mathematically represented as M is equal to Q summation delta Q0 F. Q is finite set of states. Summation is the input alphabet. Delta is the transition function. Delta is Q into summation gives us Q. So when we solve the problem, it will be more clear. Q0 is the start state. F is a finite set of final states. So this mathematical representation we should remember, so that it will help us in solving the problems.